Hey class, so here's another problem that I'm going to give you guys a few pointers on since it's a pretty wild problem. You have this crazy circuit that you can see here, and I'm asking you to find the current in one individual member right here. So we're going to try to use a loop, and I think the hints on this problem tell you want to try to do a loop that only involves this known current, and then any other currents, unknown currents, are going to be ignored. And so if you look at this and you'll be like, whoa, how can you possibly do that? That sounds crazy. Well, you're going to try to draw a loop that is going to hit a lot of the EMFs and avoid going down any different branches that have unknown currents on them. But in order to pass through this resistor here, where we're trying to find it, you're going to have to be passing through this whole member here. And so right away you can observe that yes, the current I that we're solving for here will be the same current in this member, I, but it's different than the current going through either of these two resistors here and here. But we can observe by the junction rule that really the current going through each of these two resistors will just be I divided by 2. So you have I divided by 2 in each of those side resistors and I in the main resistor. So if you go ahead and pick a direction for your current, I'll go ahead and say, let's just pick that our current is going this direction in all of these members. Then you can start doing a loop rule. So let's try it out. So I'm going to start my loop over here, and I'm going to go through these first resistor, around, and then through the next resistor, because we know no matter what we have to go on that route. So if I look at my loop rule for that portion of the journey, we can see that we're going to have I multiplied by R for passing through this first section here. Then for the next one we have plus I over 2 multiplied by R, and then we have plus I over R again. Again, that's for this resistor and then this resistor. So the question is, can we now find a path to complete the loop without introducing any new unknowns? So if I start moving along here, okay, I haven't hit any resistors, that's good. Oh, over here I'm about to hit a resistor, but I can go this way and only hit an EMF. So we can add plus an EMF. Then we continue on. I can move this way. Oh, here again, plus another EMF, plus another one. I'm not going to write all these down because I trust you guys can do it. Oh, plus another one. It's almost like a maze. Trying to go through plus another one, and so on. You can complete a loop in that manner all the way around by only adding or subtracting EMFs. So you're going to have to keep track as you go, adding any positive EMF or subtracting any negative EMF, and so on all the way around until you complete a loop, and then your only unknown will be I. If it's positive, you pick the right direction. If it's negative, you pick the wrong direction. Go ahead, give that a shot, and let me know if you have any questions.